This is the summary created from the video. Functions. The video summarizes the fundamentals of Python functions, covering their definition, structure, calls, arguments, return statements, scope, order, recursion, and overall importance in programming. In Python, functions are essential building blocks that group statements to perform specific tasks. They allow for logical separation of work, can be called repeatedly with different arguments, and serve as reusable units of computation. Functions are defined using the def statement, followed by parameters. The function body is indented and may include a return statement, which ends the function's execution and returns a specified value. Meaningful names are typically used for functions to enhance readability. When calling functions, values are passed to arguments similar to variable assignments. For example, in a power function that multiplies x by itself n times, calling power 3.5 sets x to 3 and n to 5 internally. This process inserts the function's code with the appropriate argument assignments. Functions can handle both mutable and immutable arguments. With mutable parameters, such as lists, functions can create side effects by modifying the original data. Immutable values, however, remain unchanged during function calls, following the same assignment rules as regular variables. Return statements in functions can provide valuable information, such as indicating success or failure. Some functions may not return anything explicitly, instead, just displaying messages or performing actions. Functions typically end with a return statement or when the last line is executed. Functions create their own scope, separating internal names from the outside environment. This allows for the reuse of common variable names without affecting external variables. For instance, a function could set an internal variable n to 17 without changing an external n. When defining functions, it's important to consider their order. While function definitions are read immediately, they are not executed until called. This allows functions to call other functions defined later in the code, as long as the definitions precede the actual function calls. Recursive functions, which call themselves, offer elegant solutions to complex problems. The factorial function is a classic example, defined as n multiplied by the factorial of n1. These functions rely on a base case to prevent infinite recursion, such as defining the factorial of 0 or negative numbers as 1. Functions in Python organize code into logical, reusable chunks, improving readability and maintainability. They handle arguments like variable assignments, can update mutable arguments within their scope, and maintain local scopes independent of outer environments. In conclusion, functions enhance code reusability and maintainability, with mutable arguments potentially leading to side effects. Their local scopes improve variable management, while recursive functions elegantly solve complex problems. Understanding function definition order and how functions bridge the gap between code and logical tasks is crucial for effective Python programming. Please stay tuned for more summary videos.